As Rupa said, I'm the founder and CEO of CareerCup.com, which is sort of a website and forum around interview questions. It has about 8,000 coding questions across sort of major tech companies and a bunch of smaller companies. And then I wrote 2 books, one of which is Cracking the Coding Interview, which is Amazon.com's best-selling interview book. It's sort of the deep dive into coding interviews. And then the other one is the Google Resume, and that's sort of the more sort of comprehensive job guide to tech careers. So everything from what you should read in college to what you should do if you don't have a computer science degree or technical background, up through resumes, cover letters, interviewing for both engineers and non-engineering roles, sort of the full scope. And without further ado, my slides are posted online. Actually, I don't think these ones are, but if you go to my website, go to technologyroom.com, click Speak Engagements, you can download, they'll be up later on tonight, but in the meantime, you can download one from August. Those should be basically the same slides, which are under Women Who Code. So you can find those there. So what I'm going to do today is I'm going to talk a bit about the process for tech companies, what they look for, how to do a good resume. I'm going to talk a bit about the behavioral roles or behavioral questions and how you do well in those, but a lot of it's going to focus on really the technical side because coding interviews are primarily technical. So first of all, what do the companies look for? Really the driving factor for software engineers is coding and sort of problem solving or analytical skills, or in other words, intelligence. Those generally is what actually drives whether or not you get an offer. Personality can matter. Your background certainly matters a lot to get an interview. But it's coding and sort of intelligence, or how your intelligence is perceived anyway, that really drives decisions. That said, with personality, if you come off as arrogant, that is a frequent reason why people get rejected. So personality doesn't drive it, with the exception of arrogance, which can get you cut in a lot of cases. The other thing with this is that it's important to recognize, and I'll talk a bit about what this means later on, but it's important to recognize that companies are really looking at your aptitude and not your raw knowledge, at least when you start talking about sort of the elite tech companies. But it's very, very variable. With startups, it's extremely variable. So they tend to look more at, as compared to the major tech companies, more at can you hit the ground running, do you know their existing technologies? They look at coding and intelligence just like the larger tech companies do. They look at entrepreneurial skills. So if you've started a company or done a bunch of coding on your own time, that's great. But entrepreneurial skills can also involve things like having started a marathon training group, anything that shows initiative. And then personality can definitely, and how well you fit in with the team can really drive decisions for startups. But it's incredibly variable. There are a ton of startups out there. They think many different things. So these are some good rules of thumb, but it can vary a lot from company to company. The other thing I want to add on here that I'll sort of touch on throughout my talk, but the evaluation, and this is something a lot of people have trouble wrapping their head around, but the evaluation on technical questions is very much relative to other candidates on the same question. So people will ask me, okay, I was asked this question and it took me 15 minutes to solve it. Is that good or bad? Well, I have no idea. It's like if I gave you a math test and it took you 5 minutes to finish the test, was that good or bad performance? I don't know. I mean, how many questions were on it? How hard were the questions? All that sort of thing. So much the same way on coding questions and technical questions, your interviewer is going to be looking at things like how quickly did you solve the problem, how good was your algorithm, how buggy was your code, how clean was your code. But these are all very qualitative things. They're all relative to how other candidates did. So my perception of was this fast performance or slow performance is based on asking a lot of other people the same question and getting a feel for what tends to be good and what tends to be bad. So just remember that. It's not about how quickly you solve the problem. It's about how quickly you solve it relative to other candidates on the same question by that interviewer. So try to remember that in how you think about problems. So for PM roles, I'm going to talk about PM roles sort of mixed in throughout my talk. For PM roles, and when I say PM, I mean everything from program managers, product managers, to project managers. And I lump them in all under the same sort of PM category. And the reason that I do that is that although the roles can vary wildly, even say a program manager at Microsoft, that role could vary wildly from across the company. But the questions tend to be the same types of questions asked in many different types of PM roles. So I kind of lump them all together for the purpose of interview preparation, even though the roles may be different. So for PM roles, it's about communication skills, sort of user-focused thinking, so can you put yourself in the user's shoes, passion for technology, analytical skills or intelligence, and then technical skills. So technical skills part will really vary with the position as well as with the company. For some PM interviews, they'll actually ask you to code. For other PM roles, they just having some vague coding experience is enough, and they won't really push you on it. And even other roles, they may not even particularly care if you're deeply technical. So, but these are the sort of things they tend to look for. Okay, so now I'm going to talk a bit about how you actually position yourself, how you get interviews, that sort of approach. So first of all, what do they look for? First of all, your pedigree. So what I mean by that is education. That means, how good was your college? What did you major in? Your work experience, company names, as well as your accomplishments within that company, projects you've worked on, and whatever else you have to your profile. So a GitHub profile can be really important. So that's sort of the other thing. But of course, none of this matters if you don't build a resume that really showcases this. So what does that mean? Well, first of all, let's think about how people review resumes. People who've been in a hiring role probably basically understand this already. But for those who haven't, the important thing to realize is how quickly this whole process happens. So we pull your resume out of a giant stack. We do a sort of quick spot check. So companies, schools, projects, really, really quick spot check. And we might skim the bullets to see what kind of accomplishments and impact, what kind of code you've written. And then we make this decision, and it's this all happens about 15 seconds per resume, maybe 30 seconds if you're lucky. So that's a really, really important point to realize, that if you want to make your resume jump out, you have 15 seconds to do it. 15 seconds is not enough to read everything on your resume or to get your entire life story. So you have to think about your resume in that framework of a 15-second glance. So this is basically what a CS resume should look like. So first thing you're going to see here is one page only. The exception if you have, people tend to be a little bit more lax than that if you have over about 10 years of experience, particularly if you've had many different roles. People are a little bit more lax than that, but don't make it too long. I'll get resumes that are 5, 6, 7 pages long, and it's a disaster because it's not till page 3 that I see this person has, worked at Microsoft. And if I didn't read it super thoroughly, I wouldn't even notice that. So keep your resume short. And again, this is a purely math. Think about this purely mathematically. If you compare my one-page resume versus my 2-page resume, by definition, half the content of on my 2-page resume would not have been good enough to make the 1-page cut. So that means that when I'm a resume reader and I'm just glancing through your resume, if you make your resume 2 pages, half the content wasn't good enough to be in the top half of your stuff. And that gets more and more extreme as you get to 3 pages, 4 pages, etc. So keep it short. It's really important to do that. Next thing is use a real resume format. My resume is online at careercup.com/resume. You can download there if you want. But the major thing here I want to stress is just simply having columns here. And what having just simple columns allows you to do is when the resume person is reading it, they can skim down and see the company names you've worked at really, really quickly, the roles you've had really quickly. And that means that if they can get to they can do that spot check quickly, then they can get to your real impact much faster. So use a real resume format. Keep your bullets short. Again, this goes back to the 15-second rule. Anything that's about 3 lines or longer, I'm just probably not going to read. So keep it short. Next thing, accomplishments, not responsibilities. So as much as possible, quantify these things. So if you read through just the first line of the bullets in my resume, you'll see that the first word of each of them is reduced, implemented, redesigned, promoted, created, implemented, created, built, created. That's the kind of thing that you want to look for. You want to have each thing be very specific accomplishment. I built this, I created this, I optimized this, etc. And if you can, quantify that. So if you optimize something, how much did you optimize it by? If you saved money, how much money did you save your company? So quantify that as much as possible. If you want an award, how selective was that award? Was it given to the top 3% of employees? Was it given to 2 employees over each quarter of the whole company? Quantify that award too. Next thing, if you're a more recent grad or in school, GPA can be useful to list if it's above a 3.0, is generally the cutoff people give. The one thing I want to add on here is if you went to school in a different country which didn't use the 4.0 system, translate your GPA to something that's more understandable. So this is particularly important with a lot of people who probably went to school in India. A lot, maybe all Indian schools don't use the 4.0 system, and people will list on their resume things like a GPA that's like in the 60s or 70s. And to sort of an ignorant American who isn't really well exposed to the Indian school system, this looks like a terrible GPA. So translate that, list a good way of listing that is your class rank, or you were in the top 10% of students, something like that. The next thing is 3 to 4 projects is a good number if you have projects outside of work. This tends to be more important for people who have less experience, but projects can be also a really, really good way of setting yourself apart. If you want to make that transition from being, say, a programmer at a bank to being a programmer at one of the major tech companies, doing projects outside of work can be a really good way of differentiating yourself. Same thing is if you're suppose you're a software engineer in test, so you're doing some automation code, and you want to transition to being a software engineer, projects and doing things outside of work will be really, really important and really help you to make that transition. So start some projects, list them on their resume. There's no hard and fast rules here about what can't be listed. Anything that's a meaty coding project can be listed, whether it's for school, independent, successful, unsuccessful, launched, unlaunched, anything. It just, as long as it's coding, that's what I want to look for. Next thing is technical skills, cut the fluffy stuff. Microsoft Word experience is not going to impress anybody, so cut that. And the last thing is objectives are not always, but almost always useless. They're almost always very long-winded ways of saying that you're looking for, say, a software engineering role. Mm-hmm. And when you have a computer science degree and you have all software engineering roles, and you selected the software engineering box when you applied online, I kind of got the hint that you're applying for software engineering role, right? So, 2 or 3 lines saying that you're looking for a software engineering role, it's probably not necessary. So generally speaking, don't have an objective. Summaries can be useful, but if your resume is short enough, it tends to just take up extra space and tends not to add a lot. It can be useful when you have a lot more experience and you really want to show some highlights of your resume. But a lot of summaries I read will be things like people saying, I have 15 years of experience as a software engineer. Like, yeah, I can kind of see that when I look at your resume. So it's not going to add a ton. So think carefully about what your summary is adding if you're listing that. All right, so that's the high-level overview of resumes. Again, this is online at careercut.com/resume. So you can download that if you want. All right, so now I'm going to talk a bit about the behavioral side. And I talked earlier about how behavioral personality tends not to drive decisions, and that is true for software engineering roles. But not everybody in this room is looking for a software engineering role. Some are looking for PM or completely non-technical roles. And even for software engineers, you'll get some companies where that's a really big deal, and you'll get other times when if I interview somebody and I ask them, the first question I might ask them is, oh, tell me about this project. What was the hardest part? If they really nail that and give an awesome answer to what the hardest part of this project is, and when I start asking technical questions, I'm going to be thinking that they're really smart. I'm going to be looking at their evaluating their technical performance with that bias. So, and it's preparing for behavioral things. It's a really good bang for your buck. You can do a lot with just a little bit of preparation. So I'm going to talk a bit about what it means to do well in these questions. So first of all, the goal in your response should be a couple of things. One is obviously answer the question that was actually asked. The next thing is you actually want to deliver a good answer. So you want to deliver an answer that actually makes you look good. And then lastly, you want to be able to communicate well. And this is really important because even if you don't give an answer that's really awesome, to a behavioral question, you can at least deliver an answer that shows that you have very strong communication skills. Let me talk a bit more about some of these bullets. So first of all, the way you deliver an answer that makes you look good is about preparation, first and foremost. So what I recommend people do is create this, what I call a preparation grid. So this is basically what this looks like up here. So across each column is each major sort of chunk of your resume. And then down the rows are the common behavioral questions. So what did you enjoy? What did you hate? What did you learn? What were the conflicts? What were the mistakes? Things like that. If you go to the googleresume.com, I have an example grid you can actually download in like Excel format. So that's how you do well in behavioral questions. It's first and foremost about preparing. So when you do this, when that person says, tell me about a time you faced a challenging interaction with a coworker on this project, you'll already have your answer ready, or at least something you can very easily spin into that answer. So that's about behavioral. It's all about behavioral questions, all about preparation. So next thing is, how do you actually communicate well? Well, there's two structures that I found work well for demonstrating good communication skills. The first one is what's called nugget first. And this means that basically the first thing out of your mouth is the answer to the question. What was the hardest part of this project? Oh, it was, what accomplishment are you most proud of? Oh, it was building the file system for this project. And then you go into actually explaining what it was. And what this does is it helps to focus, particularly if you're someone who's weaker in communication, either because you ramble or because you maybe just there's a particularly thick language barrier, it helps to focus your interviewer on what you're about to say. It also, if you're a rambler, it helps to focus you on what the gist is that you're trying to communicate. So next approach is what's called situation action result. And this is basically what it sounds like. You say, here was a situation, a coworker got mad at me because of blank, here are the actions I took, and this was the result. And delivering these and practicing your behavioral, if you remember that behavioral preparation grid, practicing your stories with these structures will really help you deliver a great answer. And of course, these two structures are not independent things. You can apply nugget first and then apply situation action result. So, what was a challenging interaction with a coworker? My coworker got mad at me for how I delivered some feedback. So what happened was he was struggling in this way, and I said the following thing to him. And then I took, he got really mad, situation here. And then I took these actions to blah, 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 and then this was the result. So these aren't independent structures. They're things that can be used in conjunction with each other. So that's the high-level overview of behavioral questions. Now, the rest of my talk is going to be primarily technical. So how do you, when I talk about technical questions, these can be anything from object-oriented design questions to, I'm kind of lumping anything that's sort of specific. So that's not a background question. So estimation questions I'm going to talk about. I talk about a bunch of these different topics. So first of all, for the coding algorithm questions, it's really important that you, first of all, study the right way. So what this means is, first of all, studying the basics. So this is sort of CS fundamentals, and I'll talk about what that means. But where a lot of people waste time with preparation for, particularly sort of the major tech companies, is they open up these like massive algorithms books and just start reading them. And there's an amazing amount of information there. It's a fantastic place to learn how to be a better computer scientist. But interviews don't really focus on that stuff because, frankly, your interviewer's been, out of school for typically at least a couple of years, if not 20 years. They haven't looked at Dijkstra's algorithm and like all the knapsack problem. They have not looked at this problem since they were in school. So they're not about to ask you all these questions. And even if they did, they'd be testing your knowledge of algorithms, and that's not really what they're looking for generally. So really focus on the CS fundamentals, and I'll talk about what that means next. Next thing is actually practice solving questions. Don't just read knowledge, and don't just read sort of questions and answers. So CareerCup.com has thousands of questions there. My book, Crack the Coding Interview, has another 150 with solutions. You want to actually practice solving these. And furthermore, what I mean by this is, it's not just you look at a problem, you think about how to do it, you struggle a bit, and then you look at the answer. It's you get this problem and you struggle and you fight your way through it. And you really, really, really push yourself. I'll get people who, one of the things that frustrates me is I'll get people who come to me and they're like, oh, I finished your whole book last week. and then they clearly just bought it. So they finished this entire thing. Like you really solved 150 tough questions by yourself in a week. Either you did spend every minute on that and you're really, really smart, or you looked at the back of the book a little too much. So practice really, really pushing yourself on these problems. Next thing here is you need to practice for coding questions. You're typically not going to get a compiler. You're typically not going to be in front of a computer. So you need to actually practice writing code on paper. This is something that a lot of people make mistakes with. Because, so as an example, one of my old coworkers at Google used to ask this question, which I actually think is a terrible question, but he would talk to people to ask them, rate themselves on a scale of 1 to 10 on C++. And the people who said they were exceptional, so like 8s, 9s, and 10s in C++, he then asked them to go implement Hello World. Now this is, literally what you do day one of computer science. These people who are 8s, 9s, and 10s in C++, and 90% of the time they couldn't do it correctly. Because when's the last time you actually wrote all those includes from scratch and all the parameters and all this stuff from scratch, right? When you're coding in the real world, you have templated code, you can look stuff up, you have syntax highlighting, code completion, all this stuff. And then as soon as you're in front of a whiteboard, you don't have any of this stuff anymore. So you forget a lot of stuff. So it's really, really important that you actually practice. If you have a whiteboard, that's great, but otherwise practice on pen and paper. Don't focus your preparation with using computer. Okay, so what are the CS fundamentals? So this is sort of the high-level overview of what sort of the core data structures you need to know are. And this is sort of for not all companies require this, but this is sort of for the Google, Microsoft, Amazons of the world. These are sort of the data structures they require. So the one thing I really want to emphasize, and this I think is true for any company, is you really, really, really need to know hash tables. So hash tables will come up on a shocking number of interview questions. So whatever language you're going to be coding in, make sure you know how to use hash tables in that language. And really, for people who don't have a strong understanding of these things, if these data structures don't ring a bell, or you aren't pretty comfortable with all of these, and even if you are comfortable with all these, a really good exercise to really improve your coding skills is to go and actually look up these data structures if you aren't familiar with them, and then actually implement them from scratch. It's a really good exercise for you. So nesting algorithms, again, implementing all these from scratch is a great way of preparing. The two I want to just shout out here additionally is tree insert and find and depth first search. The reason why I mention these is that all of these are important, but these are the two that tend to very often come up in interviews, not necessarily in the context of implement a tree, but in the context of design a data structure which is such and such, and it comes out to be a tree, and you need to end up implementing it. So you want to be really comfortable with those two especially. But again, a great exercise is to implement all of these. With this stuff, think about the space-time complexity. Think about the time complexity as well as the space complexity of different operations. And finally, these are the core concepts. So a couple of notes here is bit manipulation. If you're not comfortable with bit manipulation, which is very common if you've been working in languages like Java or Python or Ruby, practice this. It's really not a terribly hard concept, but it's important to understand the fundamentals. And the other thing I want to mention here, so system design and scalability, I'm going to talk a little about that later on. The other one I didn't throw this up here that is really, really important is big O time. Make sure you know that because that's going to be important for how you discuss interview questions. All right. So what if you're here and you don't know most of this stuff? A few ways to learn this. First of all, again, I don't want to scare people off and think that every single software engineering role requires it. It doesn't, but this is sort of what the elite tech companies require. This is sort of the extent of knowledge that they'll require. It's not necessarily true for all tech companies. So if you're not sure, look at CareerCup, look at Glassdoor as another good source for interview questions and get a feel for what they require. Whether they do require this stuff, here are some tips to actually get that knowledge. So first of all, the MIT Opencourseware, go through the freshman and sophomore level freshman and sophomore level knowledge, particularly their data structure and algorithms classes. MIT has most of them. I think all of their actually, and I think Stanford does too now, could be wrong. But a lot of material is up there online, so that's a good place to start. If you go through MIT's freshman and sophomore level, that's going to be basically the extent of knowledge that any company would probably require. A lot of great books. That CLRS, which is a big like intro to algorithms book, it's intense, but you'll learn a lot. The other thing is there's a lot of online tutorials. So Coursera has a lot of courses up there. Udemy is another company. They may have some. Khan Academy might. So just there's a lot of tutorials out there. I gave you sort of the outline of what the knowledge is you need to know. There's a lot of tools out there to learn this. So now we talk about sort of the last part, which is the actual technical questions. So there's a couple different types of sort of what I call serious questions. And there's product design and there's estimation questions. And these are really popular for PM roles. And they do end up getting touched on a little bit for software engineers, but they're very, very popular for PM roles. And then for sort of the software engineer computer science questions, you have coding algorithm questions, which is what the bulk of the questions will be. You also have object-oriented design and scalability questions. And then you also have factual / trivia / language-based questions. So these are things like, what's the difference between this keyword and this one in Java? I'm not going to talk about those at all because they are kind of knowledge, they are kind of factually based. You kind of either know it or you don't. But I'm going to talk about the other types today. So product design questions. So product design questions are things like, how would you design a calculator for the blind? How would you design an alarm clock for the deaf? And they can also be things like, you have $1 million and you want to redesign Bill Gates' bathroom. What would you do? So they're anything that has to do with a specific question, specific product, or more broadly. So the reason why companies ask these questions is to, one, look at your communication skills. So can you communicate well? Are you a good structured communicator? They want to look at your ability to understand the user and put yourself in their shoes. Looking a little bit at creativity, and then like sort of this business instincts and skills. And there's, in many cases, a balance between creativity and sort of business instincts and skills. So the ideal thing would be creative solutions that actually create a better product. What tends not to help very much is sort of harebrained, off-the-wall solutions that are actually terrible ideas. So those are the main things they look for. So the way you approach this, I'm just going to sort of dip my toes a little bit into talking about this. First of all, so you get one of these questions like design a calculator for the blind. So first thing is ask questions. Try to make sure you understand the problem. So they said design a calculator for the blind. Okay, when you say blind, what do you actually mean? So there's different types of blind. There's people who are just seriously, severely vision impaired, and the people who actually can't see anything at all. So it's different types. There's also different users. Like you have blind children, blind adults, blind teachers, blind accountants. What do you mean here? So ask questions. Then understand the user. So suppose you were told you want to design a calculator now for a blind child. What do blind children care about? Well, there's going to be a certain set of core features that they care about, of course. But there's also going to be emotional needs. So they want to be able to fit